to be there? Okay.
So we had some rooms where I had actually extra microphones, so that could have been useful here.
So I couldn't quite hear that.
Hear you. No, I mean, just speak into.
Perhaps. I don't think so. It's really hard to hear at this chair table because there's this.
It booms.
Yeah, and there's this weird air thing back here.
Mark and I each have a mic, so that's going to be very useful to have a chat.
Yeah, you get to hear what we think. Yay. Because that's what's important. Okay, it is now after 3:50, so enough chit-chat. I'll say one last time, and apologies for boring the folks who have been here. If you're not actively involved in this work, please save the tables at the front for people like Martin Thompson, who just walked in. So, this is the Quic session. If you're not here for Quic, you're in the wrong room. This is the ever-famous IETF Note Well slide, which describes the intellectual property terms which we're participating under. This is important. It's one of the reasons why we do standards, to get intellectual property covered. So if you're not familiar with this, please familiarize yourself. You can do that most easily by putting IETF Note Well into your favorite search engine. And likewise, we want to keep a professional atmosphere here. This isn't a professional environment. So if you witness or you feel you are being harassed, please tell someone so we can try and correct it. We have a team of people, the Ombuds team, which have an email address, or you can contact them directly and help to resolve the issue. And of course, Lars and I are also people you can talk to if you're comfortable doing that. So some administrivia, the blue sheets are going around, please sign them. We have identified some brave souls who will scribe for us. Thank you so very much, although they seem a little distracted right now. Do we have someone to relay comments from the Jabber channel? Is anyone willing to do that?
I can do it.
You can do it, Fen. You've got it. Okay,
Yeah.
That will be Lars. And before I get to the agenda bash, one other bit of administrative stuff. We have an interim upcoming in October in Seattle, hosted very kindly by F5. If you haven't registered for that, please do so soon. There is a deadline which we do intend to enforce. The details can be found in email on the list as well as on the working group homepage, which is just quicwg.github.io. And it's also linked from the various IETF tools. So we have two sessions, one today and one tomorrow, and we have a fairly modest agenda. We're going to spend the bulk of that time discussing open issues. We have a number of presentations by folks to get those discussions going. The editors got together and identified the issues that they believe are most blocking our forward progress. Hopefully, most of you were here for our session that was joint with the HTTP working group yesterday. We made some really good progress, I think, on the HTTP issues. So hopefully, we can continue that and get things moving forward. The agenda that we published is a little more than what I have up here. We're going to talk about the outcome of the hackathon on the weekend, which was for interop. We'll talk about the first implementation draft and the upcoming second implementation draft and make sure we understand that. We'll go into the issues. And then we have a couple of presentations. I think the issues will take the bulk of the time, both today and tomorrow. Then we'll go, if we have time at the end tomorrow, we have related work, Quic ECN, and also some quick multi-path experiments to go over. Any agenda bashing, any additional items people want to talk about? Okay. So, we had a hackathon on the weekend where we had, I believe, 5 implementations show up. I would say the outcome was pretty good. Do the folks who participated in that want to give a short summary of what happened? And I'll get the spreadsheet up for people to look at. Do I have to nominate someone? Patrick, since you ran the thing, that's probably most appropriate.
Yeah, I think you counted that. What do we got? 1, 2, 3, 4, 5. Yeah, 5 implementations showed up. We
Can you get
used
closer because it's hard for us
Yep.
to hear you guys?
5 implementations showed up. None of them had achieved interop of the 05 drafts before. That's the first thing we did is agreed we were going to throw out the 04 and just we labeled something 05 and went with that. The biggest issues were really settling on all the right versions. So whether that be the ALPN version, the TLS version, the transport drafts, et cetera, going forward. But you see, we managed to get in that graph that just disappeared. There we go. When you get to green and you see blocks that have C in them, that means you got interrupt all the way through encrypted data, which is really, really terrific. So protected packets and the whole bit. So, no fundamental problems found. We reported a couple issues that are, a number of things that were just purely editorial, sort of, nits of things that were syntactically wrong in the drafts, and a couple to open for consideration, but nothing like big and structural. So I think, what the working group meant to write down for those drafts is mostly as people understood it. So that's a good sign for the editors.
Great. Thank you, Patrick. So that's really promising. That's our first interop. And for me, this is a really important milestone in that we can start basing our discussion and our resolutions on running code rather than just what we think at the time.
Yeah.
Patrick?
I would add that there was, informal discussion that this is a good thing to do right before each meeting because it makes all the issues fresh in everyone's mind. So whether that's, the hackathon at IETF plenaries or our interims to set aside a little bit of time, it seemed to be a very useful thing to have on a frequent cadence.
Right. And actually, to that end, we just announced on the mailing list, the interim in Seattle, we've reformatted it slightly. So it's going to be 1 day of interop, just as you guys did, and then 2 days of normal working group meeting. So if you don't have an implementation or you don't want to help out one of the implementers, you probably only want to show up for the latter 2 days, not for that first day. Although, of course, you're welcome to come and help out or watch or drink something or something. Yeah. Any questions about the weekend? Hackathon? Okay. Thanks a lot. I think that's a really promising start. Hopefully people will realize this is becoming real.
Next time we're doing some prizes for stuff.
Prizes?
Yeah, why not? Hey.
Isn't interoperability and the warm glow of an implementation enough?
You don't have an implementation, do you?
Nope. Nope. Buy Quic. Okay. All right. So that kind of leads us to the first implementation draft, which is what we implemented for that. Although, as Patrick mentioned, we had designated draft 04 as the first implementation draft, and we ended up implementing draft 5. Everyone did, correct? Excuse me. So if we go to the wiki, the first implementation draft, as Patrick mentioned, was pretty basic. We only discussed the initial handshake and using one stream and doing a close, so some basic encrypted data transfer. And as you can see, we did pretty well at that, although it was rough going at first. They got most of that done. There's still some work to do there, I think. We've also defined or started to talk about, I wouldn't say we've defined it yet.
And actually, we had a bit more, right? Because at least a couple of implementation actually did do data like echoing or what have you on other streams.
Oh, on other streams?
Yeah. So
okay.
Not just stream 0, but we actually had like, Eckers uppercasing web service and things like that.
Eckers shouting service.
It's a microservice.
Yeah, generally, I think once people had encryption working, we were able to do some, back and forth on stream 1 or other streams perhaps, though nothing fancy.
So then I guess, the question is, what have we learned from that first implementation draft? It seems like We've learned that we needed draft 5 and to clean up a few things.
Oh, yeah.
And what can we take forward into the second implementation draft? Are people still happy with the scope that is starting to be documented here? I wouldn't call this done, but I think we need to start getting more serious about it if we're going to have give people a chance to implement before the October meeting.
Martin Duke is saying in Jabber that he's ready to talk about a second draft. I don't know if he means Jabber room or physical room, because I haven't seen him around yet.
Can you join the queue? He's not in Prague, but I think he's on.
Oh,
Martin
okay.
Duke, join the queue.
There he comes.
Let me uncover the red button.
Go ahead.
Okay, well, hello everybody. I want to first clarify what the second draft is and what it is not. This is a feature set that we are seeking to implement after this set that we are implementing today. If this initial set of features requires multiple IETF drafts, then that's somewhat orthogonal to what we're addressing here. So there's going to be this continuous iterative process with potentially multiple drafts that are going to implement the features mainly centered around the handshake that we've been discussing up to now. And what the purpose of this document is to identify the next set of features, partly for people who are already done with the first draft, but also to help steer what the first issues we need to address in terms of standards development. So there are a few things that are common to, so there's 3 different strategies that I think the group needs to discuss and decide on. The first, well, one thing that's common to all of them is, first of all, obviously any critical shortcomings of the first draft, which we don't necessarily know yet, except for what has come out of the NROP yesterday. All of the strategies have the common goal of really addressing the entire life cycle of the stream. And then we feel that we need some sort of flow control for any of the things that we're going to do, both connection and stream level. What they will not include, and I think this is down at the bottom of the document if you're scrolling, Lars or Mark, we're not going to address, I think have reached consensus, at least on the mailing list, that there's not a lot of interest in gaining key updates, post-handshake connection ID changes, and IP migration, and in PMTU discovery into the second draft. So that really leaves everything in between, and there are essentially 3 concepts. Forget about the word recommended. That was, I should probably have deleted that, but that's where I originally thought we were going. The first strategy is basically to settle the wire image. There's some fear that middle boxes are already starting to ossify on the existing visible fields in the public header and the initial unencrypted packets. And so this strategy would really focus on nailing down for good a lot of the what you can see in that image, which is a lot of the public packets, the header format. There's some issues open on how we can possibly encrypt packet numbers and otherwise toy with the public header. Really just nail all that stuff down. And then if anyone is going to try to deploy this at scale, you would also have to include loss recovery and congestion control. But the feeling here is that not only is our loss recovery and congestion control not really relevant to the wire image, but they are also concepts that are largely tested in TCP. And furthermore, the nature of both of them is that they're not really interoperability issues because obviously they're implemented mainly by the sender. The second strategy is to focus on performance testing. And so this is less about wire image and more about basically implementing all the features that are going to have an impact on how quickly Quic delivers data. So this is going to require really implementing the HTTP2 mapping, and putting in a lot of the performance relevant features like loss recovery, congestion control, zero RTT, and probably resumption. And I think that it's pretty straightforward why we would do those things. And then the third strategy is maybe sort of a mix of the two, and I've decided to call this one deployable at scale. This was Ian Sweat's suggestion. So this is one that doesn't really push the wire image too much, but there's a typo here. Oh no, yeah. So I think this has been duplicated in a weird way, but right. But basically, do the HP2 application, some of the other performance issues, and then loss recovery and congestion control, so you can actually put stuff out in the field and get experience with it that way. So that's really all there is to it. That's the progress of the discussion on the list, and I think it's time to open it up for comments and preferences as they might be. Thanks.
Thanks, Martin. So, Patrick?
Okay.
I will not stand in a transport area working group and suggest that we should deploy anything at scale without congestion control. That's good. But I think at scale might be, overachieving for milestone 2 for what we're going to talk about for most people. Right. John is talking in my ear there, making me ponder other scenarios. I would like to have us focus on particularly the handshake items, which I think has been successful so far, to get to the really core features of what we're trying to achieve here. So zero RTT and the things that enable zero RTT are a very big deal for me. So HRR was called out in one of these scenarios. I think that's a big deal. I think transport parameters is a big deal, and zero RTT. And I think there are going to be interop challenges getting there. So what we saw this last weekend was that we were butting up against the edge of TLS 1.3 deployments. What was interesting of that graph the interop grid you put up earlier was those were the Quic implementations, but the variety of TLS implementations in use was almost as broad. So Pico TLS was used, OpenSSL was used, Boring SSL was used, and NSS was used, and Mint was used. I guess that actually is as broad, that's 5. Some of them for more than one implementation. And we were able to sometimes go to 18 and sometimes to 20 and sometimes to 21, right? But as we get into these things of needing the APIs for the zero RTT features and the transport features and all of that, we're gonna start bumping into that, which I think is okay. I almost think it's a forcing function on the TLS things, and maybe we wanna put that down now and not discover we have a gnarly interaction bug later on. So I'd like to see those up front.
And send them a signal a little bit.
Yeah. Martin Thompson, one of the things we discovered in HTTP2 was that our single simple dependency on TLS was a real burden. And to that end, I think including the transport parameter exchange and the stateless retry is actually critical to all of this. I don't think we want to take on zero RTT in this next one. I'm sorry to say that, but I think we need to be a little more incremental in this. That's a big ask, and I understand that it's also kind of important that we get to the bottom of all the issues that's going to raise, because my experience with implementing zero RTT and TLS was that there'd be dragons. It's really complicated, and the way that the zero RTT will interact with the handshake is frighteningly difficult. But that's the same reason why I think we should try to keep the increments relatively small. So I think this first one is probably the best for what we have. And yeah, I think we can probably scale back the loss recovery and congestion control as Martin suggested, but I think just having them there and saying that you got to do that is necessary. Now, it might be that it's not the full-blown thing, but I don't want to see someone send every single packet that they ever want to send all at once. That would be that would not be cool.
Eric Scorla. So I agree that it would be good to get all the things that require these sort of external interfacing TLS stack nailed down soon. I think they're good. I'm less sanguine about this locking down the unencrypted wire image part, and the reason is because we still have a number of open questions about what that should actually look like, ranging from should we be encrypting sequence numbers to these data structures where are these data structures with control bits and then fixed size words following them attractive that we have to get into. So I don't think it's plausible to think we're gonna lock down the encrypted wire image. Unless we're gonna basically throw away everything in the meeting agenda now and argue about whether we should encrypt sequence numbers or whether we should have variable integer encoding. I don't see how we can lock the wire image without prematurely deciding those issues. So I'm sort of ambivalent on these questions of the loss recovery and congestion control. I'm not sure I care what them. I mean, they're obviously important, but they seem sort of orthogonal. I note that, like, you know, that I don't think does anybody do ACT timestamps properly yet? So it seems like we're actually a little far away from like having even plausible implementations of the basic things. I think neither Lars nor I properly handles ACT ranges either. So I think, you know, things are still pretty unbaked in that environment. You know, a good target here might be like, you know, having your implementations actually converge in a reasonable period of time once data has been sent. You know, I mean, so like, you know, the target we'd like here is that once you send some data, it's acknowledged, and then it goes quiescent, and it doesn't like go bong, 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 which I know we've seen a number of times. So I think, you know, maybe instead of phrasing this way, you'd say like, the implementations must be stable under various conditional losses so that, you know, and we talked about simulating that, like, it should be the case that you should be able to turn it on, send some data, and then have a bunch of packet loss in various ways, and have it like not freak out. It would be like a good start. So yeah, that would be, so I think this is, I guess the mental target I have in my head is like good enough to build like a plausible, unembarrassing, like, you know, simple echo type app on, that you wouldn't want to be able to play at scale, but you'd be willing to like show people and, you know, run in a small environment.
Ian Sweat, Google. I largely agree with Ecker for all the things I think he said. Except instead of a simple single-streamed application, I would very much like to do HTTP with the static HBAC. And one of the reasons is there is no point, in my opinion, in doing flow control and stream level flow control unless we actually run something over it that like sends enough data and like uses enough streams to be interesting. So I guess that's, I mean, I'm happy with one, except I really would actually like to run data, because otherwise I think there's a bunch of other mechanisms like we don't get to test. So.
Jana Iyengar, do you want to quickly respond?
Yeah. So actually, one thing that I've been thinking about is that, you know, from the perspective, obviously we are focusing on HTTP first, but obviously we are focusing on HTTP first, but this is a generic system. And although it's a diversion from our, you know, from where we're trying to go, I almost think being able to run H1 over this might be a reasonable thing to do, because, you know, then you don't have to actually do the HTTP integration. You just need a flow that's not embarrassing.
Jana Iyengar, just chiming in on the same discussion. I think HTTP2 over a single stream would basically be like running HTTP2 over TCP. So you got an unmodified HTTP2 over a single stream with Quic, and that would work just as well. So I personally, I think that we should specify what application we are talking about, not just say a single streamed application. And I would propose, as I just said, HTTP2 running on top of a single stream. Separately, I don't understand what the deployed at scale needs to do. I don't think anybody's going to be deploying at scale, but I think that having loss recovery that's documented in there is quite useful. Implementing loss recovery at this point, if we have it all written down, it ought to be possible to implement that and do that. To Ecker's earlier point about nailing down the wire format, I agree that the wire format is not completely 100% done. And we know that for a fact. We know that it's going to take a long time, but it also shouldn't mean that we are not going to call the wire format done for 2 years. I'd like for us to have something that we consider reasonably stable. And we might have some changes going forward, but if that allows us to start thinking about actual deployment, I think it's useful. Just this morning, I was presenting in MapRG, and one of the things I pointed out was that the Google Quic wire format is already a bit ossified. We've had experiences with this, and one of the concerns, one of the fears I have is that the longer we wait for deploying the IETF Quic wire format, the harder it becomes for us to break through middle boxes that are ossifying Google Quic on port 443.
Sure. So Martin Duke, we see you waiting there. There's a couple people in queue here who we might get through, because I'm thinking you want to respond to them. If you want to get in early or just say so on Jabber. Go ahead, Martin.
Martin is definitely ahead of me. I heard someone raise the point of flow control and all of that. I would actually say that because we know that flow control is a little bit tricky, I would take it out of this and say that not to the point that I would say we put it in very carefully and say that you are expected to respect flow control but not actually manage it. And that is to say that you start out the connection and you may and probably should send stream limits that are basically ridiculous, like infinity, and that would be a good thing. Yeah, other than that, I think we're in pretty good track. The framing maybe on the two lead-in sentences, which I did not read, probably needs to be fixed as we said, but I don't
These
think we
two
need to worry
items
about that. The lockdown, the wire image,
Oh, yeah.
no. And the deployed at scale, no.
Oh, I see.
I think that's all.
Okay. Christian.
Hi, Brian Trammell. Actually, yeah, pretty much what Ecker, John, and Martin said, sort of in that row. In that row, let's not. Strategy one without locking down the wire image looks pretty good to me. The thing that I'm afraid of when we start talking about a second implementation draft that starts looking like an application that somebody's going to go implement and then say, okay, well, this is quick, and then not update, right? We want to be careful about getting stuck at second implementation with people outside this room. So as long as we don't have the mechanisms that are fully baked, like so flow control is scary, for example, zero RTT is super scary, then we should probably hold off from saying, okay, well, we're going to actually run like full-blown H2 over this or something that looks like full-blown H2 over this because people just do it. So I'm a little scared of that. But I like where we are with strategy one without the hard lockdown.
Okay.
Christian Wittmer. Yeah, I agree with strategy one, but I mean, the idea of having to implement H2 just for tests scares me a little bit. Because, I mean, my implementation is, I'm aiming at the DNS over Quic. So if I have to basically test H2, HPAC, and all that, it'd be quite a bit. So.
Thank you, Christian.
Jörg Ott, pretty much agreement. The same comment as Christian on H2. At least I don't have my API ready yet, and I don't want to be forced into something that I can link to an H2 library somewhere in order to make that happen. I think this is premature.
Right. Just to clarify, the suggestion was to do H2 in toto on one stream. So treating it like one TCP connection. You still, okay. Just making sure that's understood. Ecker.
Eric Piscola. 2 points. One, I do think it's important that we try to get the wire image nailed down relatively soon. And so I think that means we should be prioritizing, between now and the interim, we should be collecting questions which we think impact the unencrypted wire image, and then we should be prioritizing those at the interim for debate. And I know that I am the owner of several of those, and I will work to do that. I do understand Christian's point. I was thinking about this actually as I was sitting down. I think this is one of the situations where your language choice really impacts your behavior. Namely, that in Go, it's like super easy for me to like link the Go H2 stack on top of my thing, and so I don't really care about it being about it. But I can understand if I had to pretend to be a Unix socket, it would make my life like much more miserable. I think what I do want to make sure is that people do build implementations that are like truly generic implementations and not just like integrated top to bottom, muck. And so that's part of why I was resisting the quick HTTP H2Q as the answer to this question. I don't know. I'm not sure how best to square that circle. Maybe one way to think about this would be instead of doing all maybe just doing all of H1 and have it just be like a file download application, which would actually have what Ian wants, but wouldn't be otherwise complicated.
Ecker, can you press the mic, please?
Sorry. I mean, one could imagine some sort of fake, file download application. They could just do a get over H1 that would exercise a lot of the stream issues, but nothing else. But I don't know. Maybe Ian understands what I'm not.
The queue is closed.
We're using, after Kazoo, we're closing, well, after Kazoo, we take the remote people. The Martin gets the last word.
Yes.
Jana Iyengar, I agree with Ekar on the wire image. I think we should absolutely prioritize, and that was part of my goal in raising that issue earlier on the mailing list, is that I think we really should be discussing all the issues related to the wire image and try to nail them down as quickly as we can. Prioritizing them for the interim makes complete sense. So separately, I agree that with flow control, what Martin pointed out, that not requiring just advertising a large window makes sense. I don't think that we should really be going down the path of trying to have implementations do flow control fully and correctly and testing that out at this state yet, especially because they're going to have just written congestion control, and the interactions between congestion control and flow control tend to be some of the trickiest parts to get right. And that's going to be a nightmare if we put all of that in the same interop. On the application itself, I figured I had assumed that people would be able to simply take an H2 implementation and run this on top of a single stream. But if that's difficult to do, I'd be fine with having something simpler. People who are able to do H2, but H1, you would have the same issue. Unless you're implementing it again in a simple way, in which case I don't care what you implement. You could implement your own we could implement a very simple, as Echo said, just the get and the response and one single application file transfer. An amplification service, exactly. You could implement an amplification service. There we go. A glorified echo, yes. So these are all the suggestions coming off the floor. So I think those are all fine.
While you're waiting in line, folks, try to make your point in a concise manner.
Ian Sweat, I want to say that though I recommended the idea of doing the HTTP2 mapping with static HVAC, I'm happy with anything that I think will exercise enough of the other flow control and stream kind of flow control machinery to be like moderately realistic. Like I don't really care what the actual application is. I just don't want us to implement a bunch of flow control stuff and then not like actually use it. Like, because if we're going to do that, we should just like get rid of it. Like we could just not do it.
I'm going to inject Victor from the Java room, who says, I would go with a simple application like Echo, mostly because I share Echo's concern about implementations being HTTP specific. Kazuo.
Kazuo, I just wanted to say that HTTP1 might be the easiest thing for us to implement and run it.
Okay. Now going remote, Eric Nygren.
I think if we do the lockdown the wire image, we may need to address a number of the issues listed here as the do not address list first. In particular, for example, for path MTU discovery, we very likely may want to look at whether we want things in the wire image to do in the unencrypted handshake to do some of the MTU negotiation, as well as if we want to let middle boxes do MSS clamping, and for the changing connection IDs post handshake. That's also something that we may need to think about more, define more before we lock down the wire image, because one of the big use cases for locking down the wire image is to allow load balancers to implement, and those sorts of changes will likely be breaking to them.
Okay, and now Martin.
Okay, so if I can try to capture the consensus in the room, it feels like people are mostly interested in a heavily modified version of Strategy 1. The term lockdown was probably ill-judged in the first place, and I think people slightly pushed back against it. Obviously nothing is final until it's final, but I think the intent is to converge on, something closer to the final state. So, okay, the action I'm taking forward, unless there are significant objections, is to take to build off Strategy 1, incorporate some of the comments, and I think we'll continue to iterate over the mailing list.
Martin, while we've got you, do you think you could take a go at modifying what's in the wiki tonight, our time, and we can discuss it again tomorrow?
Yes, I can do that.
That'd be fantastic. Thanks.
I noticed that the IAB chair has proposed in Jabber that we implement Gopher over Quic. Noted that we'll work on that, by the way.
IAB at the cutting edge technology. Okay. So that's the second implementation draft. If we go back, I think now we're to the point where we can discuss the open issues. First up, a discussion of the round trip time measurement and packet number echo for middle boxes and for network operators. And Ian has a presentation for that. Ian, is the latest one?
It's the one that involves the word, it's the one that's updated.
Okay.
Thank you, involves the word. It's longer. That's helpful.
I'm just looking for, okay, I think this. Let's try.
Yes, the one on the wiki is actually, this is on the wiki as well.
Okay.
So, cool. Yeah,
Great.
17 pages, thank you. It's not as bad as it seems, trust me. Passive RTT and measurement Quic. Next slide. Cool. Almost all of Quic is encrypted, as you probably all know by
Can you
now.
get closer to the microphone?
Oh. Can you hear me now? Oh. Almost all of Quic is encrypted, including ACKs, as you probably know if you're here. Network monitoring and AQM systems use RTT fairly extensively from what I've gathered. Certainly internally, I found that the people seem to want this, and it seems to be the most requested feature for network monitoring and passive monitoring of Quic. Currently, only the handshake RTT is visible by correlating the packet types. And this is an open issue. So, next slide. Yes, RTT and variation from RTT is widely used for trouble detection, network management, all that good stuff. You can figure out kind of the minimum network latency from min RTT. You can figure out buffer bloat from deviation and growth in RTT. There are a bunch of ways in TCP to do this. Most of them are actually not super exact, which is a whole different problem. So weirdly enough, if we gave the network an explicit signal, we might be in a better place in terms of like the quality of RTT measurements in Quic. And RTTs are also used on path fairly often, apparently, for AQM systems for downstream buffer tuning. And yes, Quic currently doesn't expose anything. There are some potential privacy concerns. RTT measurement enables you to correlate a packet in one direction with the packet in the other direction. That's sort of the point. Maybe, if this thing is a request and this thing is a response, that's useful. Although if you see a bunch of quiescence, then you see a request go by and then a response, it's probably about equally correlatable. Doesn't seem like a major issue, but I figured I'd call it out. And then min RTT does actually expose an upper bound on the physical distance between 2 points, for whatever that's worth. The other concern is basically people might muck this up. That's certainly never been done before, so I don't see why it would be done in the future. But yeah, and then, I don't know, they'll start managing their networks poorly or do poor buffer tuning. I don't know. Next. So we should make this easy because I don't want them to mess it up. Okay. Option one, we can do nothing. It's the status quo. Adds no complexity. It's super easy. No privacy concerns. The negative is, networks maybe have a harder time managing their own infrastructure. AQM may be impaired or useless. And the worst one to me is innovative middle boxes might attempt to infer RTT and other things from Quic. Yes, Brian?
Sorry, clarifying point. I think you misspelled the word will before attempt. It's W-I-L-L, not M-A-Y.
Thank you. Okay. Yes. So innovative middle boxes will attempt to infer RTT if we do not give them this to them, and goodness knows what they will do, but it probably will ossify the wire format more than we would like. So it actually may cause negative consequences for Quic in terms of ossification. Next slide. Option number two is one we've been talking about for a while. A packet number echo. Essentially, Quic has packet numbers. You can see them as they go by in one direction. And you can echo it in some specified portion of the packet in the packet header, in the unencrypted portion, but the authentication portion on the way back. So, I see 3 go this way, 3 comes back the other way. And, you can correlate the packet and get an RTT measurement. This becomes a little bit more tricky if we encrypt packet numbers, but it still is a viable option. So, you know, say you say 4 bytes of gobbledygook go in this direction, you can match it with the same 4 bytes of gobbledygook in the other direction. Just might require a little bit more memory.
Yeah. How can we make passive measurements if it is encrypted?
The idea would be that if the packet number is encrypted, that still that value that was on the wire, the value that the middle box sees would still be like reflected in the other direction. And so you'd still have the same token essentially to correlate the two numbers. Yeah, instead of becoming a packet number, it kind of becomes a random token.
Yeah. So Martin Thompson, to explain here, you will still see the edges as this bit shifts when the packet numbers are encrypted.
That's the next one.
That's the next one. Oh, this one. Sorry. Yeah, gobbledygook in one direction, gobbledygook in the other direction works fine.
Yes. Yes. Yeah. Oh, some negatives include the fact that it does consume a few bytes on the wire, which is not the end of the world. The more annoying part from an implementation perspective is it changes your payload length, which is a little bit just tedious to deal with it based on actually writing code that changes payload length. And measurement may be fairly memory intensive. I mean, I'm not an expert on this area, but you know, there's definitely more state to save if you have to save all packet numbers that go by in one direction and all that go by in the other direction.
Particularly when they're variable length.
Sure.
Yeah. So Martin Thompson, the other con that you didn't mention, which again was kind of trivial and probably not even worth mentioning, is that it does allow packets to be correlated. Part of the point of encrypting your packet numbers would be to prevent correlation, but this explicitly re-enables that.
All of these mechanisms
kind of interesting.
Explicitly enable packet correlation. That is exactly what
that is exactly the point. Yes.
That is the purpose. If we have not succeeded at that, we had failed at creating a good mechanism to do this. So,
Hi, Brian Trammell. On the point of how much memory it takes to do this, like obviously if you're looking for a whole bunch of tokens, you need to save a flight of tokens that you might be wanting to look for. If it's more sequential, then like a lot of the things that I know about, like just look at sequence numbers and do a inequality, right? So you can do it with as few as one sequence number per thing, right? So like the encryption versus non-encryption does have an impact here, but at least for the on-state requirements, you can even do it in hardware if the numbers are going up.
Yeah, right. I mean, both are implemented.
Could I suggest that we let Ian go through the options and do clarification questions only and then discuss them all at the end? Because otherwise...
we'll be here for a while.
Yeah.
So this may be a clarification question, and feel free to tell me it's not. What happens if you encrypt the packet numbers in this case?
We were saying that essentially it will be gobbledygook going in one direction and we will reflect said gobbledygook in the other direction.
Okay, so thank you.
Janang, a clarification question. The receiver simply echoes every packet number it receives, but if the receiver is ACKing, for instance, every 2 packets, what does it echo in this case? Is that clear in the proposal?
The current proposal specifies that you must echo at least once per round trip time.
Right.
And that's all I believe that.
Okay.
Yeah.
Yeah, Kulevin, adding to your list, first of all, the complexity of the measurement really depends on how much you reflect, right? So if you would just reflect on every packet, it would be super simple. And also, I think the ability to be able to decide not to reflect is rather something that we should have, but there could also be cases where you decide you reflect on every packet because you just have the space or whatever.
Not really a clarification question there, yeah.
It's not a clarification, it's a clarification point because there's a list of pros and cons that we're discussing and I'm adding to it because like that moves actually from the cons maybe. And what I want to add to the pros is like it also can be used as a confirmation signal because it correlates to packets, right? Okay. Very clearly, and we need this sometimes and yeah, might be pro.
That is a good point. It is a confirmation signal which has a lot more entropy than the other case, the 1-bit approach. Next slide. Okay, now we get to the fun part, animations. All right. So option number 3 is 1 spin bit set per RTT. So essentially, you can see there's 1 packet number with the little 1 set there. See up there, and all the others are 0. And as you page through the slides, it will gradually move around to the server and then come back to the client. And there, great. So basically, it just travels around in a loop. The pros of this?
Clarification question. That is not, okay. You have the PR coming next?
If you wait until after slide 17, you'll be happy. I think.
Okay.
Let's let him finish.
Have you heard of colors, Ian, by the way?
Yeah.
Apparently. Well, we talked about colors and we decided that might be.
No, I mean for your slides.
Oh, okay, yeah, okay. Okay, great. So 1 bit for RTT provides you downstream RTT, provides you total RTT, and it also provides you approximate congestion window, since you know about how many packets went by between the time you see the bit like flip each time. So that's very nice for like bandwidth measurement as well as RTT measurement. The con is that it must be restarted once it's lost. So as you can imagine, if this bit is going back and forth and boop, gets dropped, then A, you lose a signal, and B, you have to have an algorithm for how to restart it. That can be moderately tedious. You guys really are asking clarification questions?
So I think you have the proposal wrong, I think. And
There
so
are
that-
2 proposals.
This is one of the proposals, and there's another
Yes, they're
one?
very similar.
Okay, right. I didn't think this was even a candidate.
No, that's 3 and 3A.
Okay.
Okay.
Yeah.
Sorry, this is DKG. I have an actual clarification question.
Okay, cool.
Can you define the term downstream RTT for me, please?
Oh, downstream RTT is essentially the RTT from the observer to the receiver and back.
So it's the point from you to the.
It's on the right hand.
So
towards
you're
the right
measuring
of
it
the
from the
slide.
middle box. This is a flag that's set by the middle box.
It's not set by it's observed by the middle box.
Guys, you need to use the microphones, otherwise it's not going to work.
Yeah. It's observed by the middle box. It cannot be changed by the middle box.
Okay, but you're not talking about just RTT measurement from the endpoint, which is already totally covered.
Totally doable. Okay. Yes. This is passive RTT measurement by someone who does not have the keys.
Clarification question. It is
Just
one.
because you all say it doesn't make it so.
I've been good about this so far. The fact that approximate condition window is being exposed might also be a con.
That's not a clarification question. Please sit down.
That's a valid point. Thank you, John. That is a valid point. And yes, yes. I want
Is
people
it
to understand the
such
design
that I want to confirm that this is my.
Man. Wow. Like,
Don't help them, Lars.
I saved the best for last. Just wait. Okay. So this must be restarted once lost. However, it is very, it does not deal with issues with reordering. So it's very easy to deal with reordering in the circumstance. You just see reordering. It's fine. You don't have to do anything special in the reordering case.
Mike.
They're horrible, aren't they?
What do you mean must be restarted once lost?
I mean that when the packet that has the bit set is lost, then suddenly you have a bunch of like zeros going around, and one of the peers must like know when to like start marking again so they can start the like packet going back and forth.
When we understand how to do that?
I mean, we have some text,
okay.
John and I wrote it is possible. But it may take time to do, right? Basically the typical algorithm is like only one of you starts it, like only the client can start it. And the client starts it when it realizes that like the signal has been lost based on loss detection or some combination of it not being repeated back by the peer. It's not intractably hard, but it's not trivial either. Okay.
Okay.
Yes.
Go to the next slide while we can.
Thank you.
3A.
This is the one that everyone apparently wants. Option 3A has the identical bit value for an entire RTT of packets. The connection initiator, the client sends packets with its bin value, say of up, The peer reflects the spin in response, so that's the same value. And then the initiator flips it every time it hits it. So as you will flip through slides, the little ones will go around, and there we go. So it provides you downstream RTT, total RTT congestion window. It's highly tolerant of loss. I should have put that in the pros. I apologize for not putting that there. So you can lose any one packet, and as long as your entire flight size is not only one packet, then this works swimmingly. It does require the endpoints to kind of fix the signal up upon reordering. Otherwise, reordering can sort of degrade into essentially noise in the worst case situation, because the reordering just sort of like matches up this 1 and 0 bit stream into binary gobbledygook. And the middle point may have to do some filtering to kind of get a correct RTT estimate, because in the case of reordering, you may say, see 0, 0, 0, 1, 0, 1, 1, 1, 1, 1.
So Martin Thompson, just one little point to add here. If the packet numbers are visible, as they currently are, you can use the packet numbers to deal with some of that reordering.
Yes.
If they're encrypted, then it gets a little tricky.
If the packet numbers are visible, then fixing this in the middle box becomes essentially trivial. And it's equally easy to fix this reordering on the middle box as it is on the peers. Yes.
So just, that's your last slide, right?
I think.
Yes.
Yes.
So we may now
Still
discuss it.
clarification. It's Chris Seal, Hutchison. Just to understand this, when you say that it filtered out to account for reordered spin bits, do you mean that you can always tell that you've got an incorrect result and therefore you can throw those away? Or my main concern would be mismatches, which give me a false reading.
I think you mean smooth.
So what would actually happen is kind of what I verbally gave as an example, which is you would have a string of zeros that would be about to change to a string of ones, but one of the ones would get reordered in front of one of the zeros, so it would go 0, 0, 0, 1, 0, 1, 1, 1, 1, 1, 1, 1. And so that's why I was saying you may have to apply a smoothing filter, like, you have to see 3 packets in a row with the same bit before you like decide it's an edge or something.
So the answer is you can throw away bad results.
I guess that's true. Yes. Actually, however, if you still have packet number exposed, it's easy to throw away bad results. You can just discard reorders, as Martin noted. So as long as packet number is exposed, I guess I would say from a technical perspective, it's pretty clear to me that 3A is strictly superior to 3 in terms of robustness.
Jana Iyengar, I think 3A is superior. Even the fact that it's resilient to loss makes it much better than option 3. I like option 3A if this is something that we want to do. In the cons on RTT estimate being filtered for reordering, that's something that middle boxes have to do anyways for TCP. It's not new for Quic. As you said, if packet number is visible, then it's basically the same thing that they do for TCP anyways, even today. If it's not visible, then they have to do something slightly different. And I honestly don't think that it's a major issue. They will anyways be filtering RTT. Nobody uses raw RTT signals. It's almost always filtered.
Andrew McGregor. Relative to this discussion, I'd just like to point out that I was just looking, and in a quick search, I found 4 different spectral methods for finding RTTs of self-clocked window congestion control protocols that require no labeling on the packets whatsoever. They even work when it's inside an ESP tunnel and you only have 1/2 of the connection. So you can't hide this information even if you're trying to hide it.
No, I'm responding. Jana Iyengar, very quickly to Andrew. You said self-clocked. That may not necessarily be the case. For instance, BBR is rate-driven, which may have very different characteristics.
It has enough of a self-clock because it has to repair for retransmissions.
It's not a requirement of the protocol, though. Self-clocking is not a requirement of the protocol. Although I think your point is that you can measure RTT using some of the techniques. I think Ian mentioned this earlier, right? That middle boxes will end up doing something to find us because it's a signal they care about. And the question is whether we should expose something so that the endpoints are free to do whatever else they want to do. They may not do self-clocked congestion control, for instance.
Certainly this makes the middle box's job easier, and maybe that's worth doing.
Ian, Al Morton, what's your policy on, after you set the length of ones and the lengths of zeros in packets?
It sort of naturally sets itself. So essentially the client would initiate a value out of quiescence, say like 1. It would hit the peer, the server. It would come back as 1. And the first time it sees a 1, it would flip to 0.
And would you keep it constant?
It's essentially
It helps a lot to keep it constant. I think then to keep the lengths of ones and the lengths of zeros.
It would end up being the length of the congestion window, actually. So it ends up being kind of the bytes in flight.
Okay.
Because basically one edge will go by exactly once per RTT.
Right.
Yep.
We really need to have conversations at the mic, please. Patrick.
So if we're going to do one of these, please, God, let it be 3A. But I don't think that, I really appreciate the presentation Ian gave on the initial slides. I think it described the trade-offs well, and I think essentially exposing any information to the path here is not commensurate with the potential long-term loss of what we don't understand about traffic analysis and that kind of thing. I don't think the win here is nearly big enough to start going down that path.
Chris Seal, I think broadly for me, 3A is a big step forward. I do work for an operator, and we do with TCP use sequence ACK measurements network-wide to find queue delays and find hotspots in our network, and therefore do network planning and fix. And actually, it turns out to be a much earlier warning sign of network problems than traditional methods. The other thing I'd say is the discussion earlier about even if the packet header is encrypted into gobbledygook, I think you said that it would still be the same gobbledygook that came back. So RTT is already exposed, is that right?
That was a different option.
I know it's a different option, but my point is whether, if it's not encrypted, you can do it. If it's encrypted, it sounded like you could do it. And this just makes it explicit.
Oh,
yeah.
It really needs to happen at the microphone, and in order to make it happen, people need to be brief when they talk.
Can I actually ask a question?
Go, Ian, you have, you have your own mic. You can
to build on that point, can I see a show of hands if people are willing of how many people who would consider using this information if Quic exposed it? Oh, well, that's a bigger number.
I would say 20-ish. Yeah, okay.
Thank you very much.
What would you do if it wasn't there? No.
So, Gory first. 3 and 3A are like processed data, and that may be okay, but I mean, the real time I want to see these numbers are when things are going wrong, when we've got packet loss, when we've got varying RTT. And I don't quite figure out how 3A and 3B work when I'm trying to measure jitter and variation of RTT. I mean, I know that's not what the transport is trying to do, but that's what I'm trying to use to debug the AQM or layer 2. So
that's a fair point. This, in cases of heavy ACK aggregation, this is going to be a fairly noisy signal.
Yeah. Let's switch to the virtual queue just for a second. Martin?
Yes. My question is, what would be the must, should, may status of this for endpoints, and what is the impact on a middle box if it is, assuming that it is optional? Have you thought through how hard it is for a middle box to figure that out and therefore not have really wacky RTT measurements?
I think it's up to the working group to decide if this is must, should, may, in my opinion. I have opinions, but that's not really the point. And then in terms of middle boxes being able to tell whether an endpoint is doing it, we can specify something like you must do this on, the first or you must start with some value on the first flight or something, and presumably fairly quickly you could tell what's going on. I don't know, but it's a good question. I haven't really thought through that.
A clarification. It's not in the PR yet, but one trivial way to make it known to middlebox was done or not is that you only use the value 1, the up bit, if you do it, and otherwise you leave it to 0 always. So if the middlebox never sees a 1, it knows that it's not there.
That's a good recommendation, Christian. Thank you. I am presenting Christian's PR to give him proper credit. That is PR 609.
This is Daniel Congilmore from the ACLU. I think I agree with Patrick McManus about not wanting to add this, given that we don't really know what the consequences are. The fact that there are, I think somebody said about 20 people in the room who would want to do something with this if it was exposed doesn't, I'm not sure whether that was a poll intended to indicate that we should do something because more people do it or because people won't. I'm frankly concerned given what the network operators have done with other information that we've exposed in the past, like port numbers, and we saw how that worked out. So the idea that we're going to deliberately expose something to the network operators because they want to do something with it doesn't strike me as an argument for adoption.
So the tussle here is that it's been repeatedly sort of requested that there's information that's useful or maybe useful for traffic management, and part of the Paris NRM, we try to find the smallest amount of information that could be leaked, which is in this case the 1-bit scheme that would give the operator some information that they claim they need to manage their networks while at the same time not exposing anything internally to Quic. Right? But this still might be too much, right? But this is we're trying to find a
I understand,
middle ground
and I
here that might
appreciate
not
the
be-
effort to minimize it and to scope it. But like port numbers are an example of that, though, of here's a limited set of how you can do multiplexing. And we know that network operators have not only damaged the port space, but they've gone into much deeper packet inspection beyond the port space. So it's not like if we give them a little thing, then that's going to be enough. It's not going to stop people from the con of option 0, right? The middle boxes will still do whatever crazy other things that they want to do. And yeah, so like the fact that we offer something doesn't mean that it won't actually continue to be a problem. And we don't know what the negative consequences will be of having.
Understood. I'm going to quickly close the line after Roni just to see how long it takes to drain, and maybe we'll reopen it if we have time left. But there's a virtual Brian behind. You just insert yourself, Brian, whenever you need to.
Brian has that ability because he's a scribe.
Okay.
God.
Be brief.
Yeah, I just want to say, as somebody who's building stuff that uses this information, I think 3A is the only real proper option here that we should go for, and I think it should be mandatory, and I would be super happy if we also had packet numbers, but I can live without them. Thanks.
Jean Rouge, Fastly. Two things. One,
go really close.
Yep.
To the mic. Really close.
Okay. So one thing is I can get a feel for whether there's any way of enforcing whether the sender is being honest about what he is informing the network. So is there any feel for that?
The peer could enforce that with some work probably, but it would, I mean, that'd require quite a bit more state tracking. It's possible.
The other minor comment is, in the same way that there's no assumption about self-blocking, I'm not sure there should be assumption about the reverse path that the packets follow, because you might, as a middle box, only see part of the reverse path, and packets might be flowing through the other, like another path that is invisible to you in the network. And depending on that, whether you take into consideration that might affect different options differently.
Yeah, I guess I think that's a good point, but I think in that case, probably that's a very challenging case to monitor in general.
That scheme actually allows for one-way observation of the RTT, because the transition from 0 to 1 and then back from 1 to 0 happens after one RTT.
Right.
Jana Iyengar, I think it's valuable to have a, not discussion right now, but we do have an existence proof of something that might work. but I don't think that's necessarily means that this is something we will do. So knowing what folks think or about whether we should do this or not is still a very useful thing. And yeah, that's about all.
Hi, Colin Perkins. So I guess there's 2 points. Firstly, if this is likely to be problematic, we should have heard that the technique is problematic because TCP has been doing it for many years, has been exposing this information. So if there are problems in exposing this information, they should have surfaced by now. But if there are problems, then rather than saying, here are the vague, we don't know what the problems are, but they might surface in the future comments which have come out, then we should list the problems in exposing this RTT information and have that discussion. Because I've heard several people say, we don't know what the problems are, but something might surface if we expose this. So in that case, let's...
Emil, the queue's been closed.
Yeah. So the point is, if there are known problems, then we should document them rather than saying there are hypothetical problems. The main reason I stood up, this is obviously providing information once per round trip time. And you can get one round trip sample per round trip time. A lot of the uses for round trip time sampling and measuring the round trip time are to identify dynamic problems. Looking at how the delay changes during a round trip time, for example. And that's not possible using this mechanism. Now, you may or may not consider that a problem, but it is a difference from what's possible using the analysis in TCP, for example. And
yeah, I would agree. Yeah.
Ted Hardy, before I begin, to the chairs, Brian was actually behind me in line. If you're, okay, I was just going to say, if you're going to just have one more person, please let it be Brian, because he certainly knows more about measurement than I do. I got up when DKG was making his point, and although I certainly agree that there are forms of traffic analysis that this would allow, I think those forms of traffic analysis are also the forms of traffic analysis that are basic to network measurement for network planning. Having done network planning on a bunch of different networks, being able to see when the round trip time is changing when you're looking at a link that crosses more than one peer is a pretty basic form of analysis that you use both in traffic engineering to see whether or not you're going to use that particular link in the future to talk to that peer or other things. So while I certainly understand the concern, I do have a related concern that if people don't see Quic as performant as the TCP TLS version of the protocol, because it can't allow the networks to do the network optimization, then there is a trade-off here that we're making that we should be making with our eyes open.
Thank you. Brian? What Ted said, Brian says. So yeah.
I wonder if we actually want to reopen the queues, since this actually, you guys are very good and drained it fast, because I think it's a little bit, well, fast for transport. Because I think a little bit more discussion would be helpful. Ecker.
Yeah, Eric Pascola. Colin, I must say I'm baffled by your argument. We know TCP has horrific privacy problems, and the reason that we don't have privacy problems for this particular bit is because the privacy problems it has are so terrible that, like, no one bothers to write papers on how the bits it doesn't expose are bad. Like I can show you 10 papers. I can show you any number of papers about packet information leaks from packet. Are you let me finish? What you're saying is what you should be saying is that you're not worried that we should be able to deduce information.
Ecker, could you please slow down just a bit?
Sure. You seem to be saying that we should have to deduce specific attacks from the specific information leak, but there's plenty of attacks from the information leaks we know we already have, and nobody bothers with weaker leaks because we have stronger leaks.
Colin Perkins, what I was actually saying, there was a previous comment at the microphone that we should not expose this information because there may be future unknown privacy risks from doing it, which would be new because of Quic. Well, this information has been exposed for a long time, so it's not new because of Quic. We may want to not expose this information because we are aware of privacy risks with it, and that's fine. But don't say this is a new thing we're exposing, which introduces a new set of privacy risks, because they've already been there. So if there are risks, then let's
let me try
talk
and
about what they
so
are,
you're saying
rather than
the
saying
privacy
there
risks
are
that-
unknown risks.
So let me try to rephrase it. So do you think the privacy risks that this has are a subset of the ones we currently have with TCP?
Yes. Yes. And if those risks are known, then let's document those risks rather than saying there are unknown risks with TCP.
Andrew McGregor, should someone clarify what I said before about the spectral methods? Sorry, Andrew McGregor.
Can you tilt the mic a bit, because I think it's actually pointing up and everybody sort of speaks to the side of it.
Yeah, and this particular mic has a very small hot zone. Okay. I should clarify what I was saying before about the spectral methods. They don't actually require the self-clock, but of course you have transactional things happening inside the protocol, and the mere fact that a response comes after the query is enough to key off that method. Similarly, the mere fact that a retransmission comes after the loss is enough to key that off. So unless you're prepared to put a randomized and relatively long delay inside the end system, you can't hide the RTT from a passive observer. It doesn't matter if there are any bits in the packet at all.
I will clarify. I tend to think you're right, but I will clarify one thing, that it's very difficult in Quic to tell what's a retransmission.
It doesn't matter. The method doesn't care.
Okay, okay.
The method doesn't care. It's just the fact that when you retransmit, there's a hole, and then there's another packet at some time that is correlated by the RTT, and that's all it's detecting.
You're right.
Right? Yeah. So it doesn't need to be able to tell anything about any of the packets except that they belong to a flow. Right? Yeah. And it can even get you the RTT spectrum of an aggregate, which actually from a traffic management point of view is awesome, because that's exactly what you want to know, and you don't care about any of the individual connections, right? But you can't hide it. It just can't be hidden unless you're prepared to make your performance suck.
Tommy Polly. So just in general, yes, I like 3A better of all the flavors, but kind of just following on what DKG was saying and trying to kind of ask a question back to that, he brought up the point of the kind of comparison to the privacy problematic points of ports, which is a small piece of information. My impression of this is that it does seem fairly different, because especially if you did mandate that all Quic clients were marking this bit in this way, you would see essentially uniform behavior across all implementations. And essentially all you would know is that, yes, they are doing Quic, and they are on a network which I may be able to understand the RTT of anyway. So ideally, I imagine it wouldn't be giving me any more information about the content of what they're doing, because I could already infer that they are doing Quic because they're doing something over UDP that looks encrypted. So I'd like to understand more if other people have comments on why this would be potentially more equivalent to something like port privacy.
Hi, Brian Dremel. What I haven't said yet is that I do think that this is an important thing to be measurable and easily measurable in a way that you don't screw it up very much. Because if it's like input to an AQM, again, what Ted said, if it's an input to an AQM and you get a crap signal as the input to the AQM, that might turn into, oh, Quic is bad, we should turn it off. And we have a big red off switch for Quic, right? I mean, block UDP 443 and it goes away. And I want to give as few people as few reasons as possible to do that. With respect to, I'll actually, Ecker's in line behind me. I'd love him to give a citation on a traffic analysis paper that looks into the round trip time secrecy of a path. Right, so I've read a lot of traffic analysis papers and a lot of stuff on timing, right? There's a lot of stuff that you can figure out about the implementation by looking at timestamps. This isn't a timestamp, right? This is as close as we can get to a pure network RTT signal that we can give to the path, with no access to any of the semantics of the underlying application layer logic, no access to any of the semantics of the underlying transport layer logic. There's no, you can implement this in a completely separate piece of, you can implement this in hardware, you can hardware accelerate this, right? It doesn't even need to touch. So
it doesn't even need to be Quic, technically.
It doesn't even need to be Quic, technically. You could give it another name, but I'm not going to suggest one because that will derail And I'd like to get, it's the minimal UDP substrate. It's called minus. And I think this is the one signal in the minimal UDP.
Glad the plus set is shrunk into 1 bit, right?
I figured if we shrank plus to 1 bit, people might not hate it as much. I'm really interested in concrete examples of why this is risky. Because if there's a risk here, then we should look into the risk-utility trade-off. But to me, the utility looks quite high. The risk looks rather low. As Andrew says, a network RTT hiding transport is a very hard thing to build unless you just go to like slot reservation systems like Aloha or something like that.
So DKG is 2 behind you.
Yeah.
And I would sort of volunteer him a bit more time than the average Q speaker because he seems to be the only one who's very much, and Mia is shaking her head, I'm going to do it anyway. Because he seems to be the only one in the room who wants to argue the opposite side, and people are asking, why is this risky? And I want to give him some time to explain.
No, and that's not a challenge. I actually want to understand this.
Okay.
Hi, this is DKG. So I want to make a couple of observations here. I believe that Andrew McGregor's point about traffic measurement that can be done without any mechanism like this is about a domain, a network that's under one set of administrative control. No? Okay, sorry, I haven't read that paper. If I can see the response time, I can geolocate to some degree of some set of approximations, which I can't otherwise do. So if anybody doesn't think that location is an issue that has some privacy risks, then come talk to me. I'm happy to point you towards people whose location is potentially problematic. It gives you timing information about the endpoint and how it processes packets and how it responds to packets. It gives you some information about what protocol is being run. Not every protocol requires an immediate response to every packet. So you might send me a packet and the protocol that we happen to be speaking might be might have a long delay because something else is happening. It might give you information about battery life on the device because your device might decide to not send information. So there's a range of things that I can infer if you're willing to give me information about exactly when you receive packets and when you sent them out. So now, there may be other things that I don't currently know, and I'm kind of upset to hear the argument made here that it is the obligation of the people who are concerned about potential privacy risks to give a full enumeration of them when the history of the IETF has been to implement things without consideration of privacy protocols at all, privacy considerations at all. And so we need to have a precautionary approach here. We're trying to do something that's better than TCP. And so yes, even with this, is probably better than TCP, but let's try to do as well as we can. I don't want to have to do Quic v2 when we find out later that people are getting, I don't know, getting busted for stuff, or, network operators are colluding to keep people off the network because of the round trip time. So I agree that this is a small point and part of a bigger picture, but we should be minimizing what we expose to the networks.
Okay, the queue is exploding, so let's keep it brief as we can.
Can I add a follow-up point? And I'm not sure if this actually mitigates your concern at all. And I now regret not sending my slides to you beforehand because I think the concern slide would have been much more compelling had you written it. And I'm sorry about that. But this mechanism, 3A in particular, is simple enough that if we wanted to turn it off, everyone could. Now, the question of whether that's a practical thing to do 10 years from now, maybe not. But in the next few years, certainly if we thought that there was a privacy risk that had, we could enumerate, it would be possible to turn it off. But we would have to coordinate in turning it off. Otherwise, it would be identifiable. But I mean, at the stage we're at now, we're years from the point where I think you could probably get it turned off in pretty much globally, probably in the next 2 or 3 years fairly quickly. No? Okay. Well, we could turn it off quickly. And Chrome.
Mia Kulevin. So on a high level, I might even agree with DKG because, you know, sure, we should do all this, but like if I look at Quic, then all the examples he just gave, you can get this information anyway. So I think we should really talk about, you know, what's the concrete case here? What do we do right now? If the request is to consider privacy in the decisions we make, I think I fully agree, and I think we're doing this. Otherwise, we wouldn't have this discussion. But so my original point was that while it's not really clear what will happen in future, there might be negative impacts by exposing this signal, but there also might be negative impacts by not exposing the signal. And I think the negative impacts by not providing this information are much clearer to me, like on network management, because this information is very much used. And so maybe it's useful to look at what we learned so far. So TCP was designed not with having in mind to expose explicitly information to the network. So everything was exposed, everything was modifiable. There was like no integrity protection. So that's something we learned. So we learned that if we expose information, it should not be connected to any internal semantics. It should only expose the information that we want to expose, and we should protect this information. So that's much better. And we also learned from the past that this information we accidentally exposed has been proven very useful and is probably the right information to expose.
So may I ask you a quick, so I'm trying to you made two statements. One is this information is available already anyway. And then you said, we need to expose this. So those two things in my head are conflicting. So because if it's already there, right, then we don't need to expose it because it's already there.
So that's a question of complexity. Like, of course, you can get this information if you put more complexity in, or we can assist the network and just give them the information. And then we also avoid that they do some random stuff because they get the information they need in an easy way.
Okay.
I'm looking at the time and looking at the fact that our AD is last in queue, and I think it's an appropriate place to cut the queue probably after Spencer. So.
Yeah. So I guess I want to make several points, but I'll try to make them brief. First, I want to remember the priority constituencies here, and our loyalty here is to the end users, so at least mine is. And so if this is like we must inconvenience the network operators to make the end user's life better, like that's I think the appropriate decision to make. Now, if we make the network unusable, it's a different story, but that's not what I'm hearing. The second point is the one raised by DKG, namely that what we're trying to do is make a protocol which has superior security and privacy properties to TCP, and so that should be we should be trying to remove as much signal as we possibly can. And so I don't think the burden of proof is on the people who want to move that signal to demonstrate that signal is potentially meaningful. The whole reason why you want the signal is because you think the signal is meaningful. And so so the very fact that leaks information means it has privacy implications. So I think that the suggestion that requires a concrete attack that describes a specific privacy problem, I think is quite baffling. I don't have one specifically I'm not sure that's been published, but I do have one I'm going to suggest to you right now, which is which is basically timing of packet decryption. So imagine you have a situation in which you can manipulate from the wire without decrypting the packets, the packets in such a way that the receiver will immediately respond with some sort of error. The error will be encrypted. So for instance, the case when TCP often uses where you have out of order packets cause immediate acts, right? Sure. So imagine you have a situation where by manipulating packets without decrypting them, you can cause the receiving implementation to immediately generate a response. Now what you have is a way to, now you have via this mechanism is a way to immediately detect which packets respond to which other packets, and therefore you have an ability to measure precisely the packet timing, processing timing. So if you have a non-constant time decryption implementation, now you have a potential way to extract the decryption key. This can't be done.
Wait, I think I'm missing.
Because the bit causes an edge flip.
To be clear, I can already do this today without this.
Why?
If you twiddle two packets.
Yes.
Then you are going to, as you said, generate an which is going to be easy to identify.
But you know with some confidence, but not full confidence, that packet wasn't organically generated. And if you have a situation in which packets are flowing aggressively, like for instance, people are generating chaffing traffic, for traffic analysis differentiation, then it does become quite difficult. I didn't say this best attack in the world. I said you're leaking information about a private piece of state about the recipient. As I say, I don't think there are a lot of papers written about this merely because we have not yet, I mean, the way security papers work, right, is you start planing down all the signal. And when one signal is still there, you don't plane down more signals. And so when we've planed down the signal, we will then find attacks on the signals that remain. And so to demand that we have an attack on a signal that is a very weak signal when there are already attacks on the strong signals is just not reasonable in terms of how security research works.
Dan Drutzer. I think what brought us to this discussion is a set of requirements that for the first time since we've been talking in Quic were very clear what I think what we want, what is needed. So if the argument that the requirements are not valid, I'd like to understand if people are arguing about what is needed in the context of RTT per link, on the path, and I think the solutions that are being presented, we need a solution, period. It doesn't matter. The 133A seems to be a good balance between privacy and manageability. But I think we need to acknowledge the fact that there are clear requirements, and if the requirements are not clear, we need to understand why they're not, first of all, not clear, and second, why are not they're accepted. But in general, I think it would be a good thing to do this, and it's necessary for network management, not just for operators, but also for enterprises. If we want to get adoption of Quic in the enterprise space, I think it will be absolutely necessary. Otherwise, it will fall back to TCP, which has the security problems that people claim. So
I think the requirements are clear. The question for the working group is, do we want to address them, right? Which is option 1 was no, we won't, and options 2, 3, and 3A, and there might be others, are proposals for how they could be addressed. But I think the requirements are clear. That's what we spend a lot of time in Paris on.
Jana Iyengar, yeah, I'm going to echo one of DKG's points, which I think is worth echoing again, that the burden of proof for a privacy bug is not on, I don't think we should wait for a problem before we try to address this, because by the time we find a problem, it's going to be too late to address it. If Quic actually has, if there is a privacy issue with this particular bit, and we find out 3 years from now, this is going to be ossified, and we will not be able to take the bit back. So it's important that we consider this question now and not wait for something to go wrong before we say, no, we shouldn't have this bit. I also want to add that one of the contending things with AQM has always been and continues to remain endpoint congestion control. And we know that congestion controllers like BBR are actually also working on minimizing queues in the network. This is something that works towards the same ends as AQM does. And it's something that we see, for instance, deploying BBR for TCP traffic at Google and for Quic traffic at Google has shown substantial reduction in round trip times observed in the network. So it does actually reduce buffer bloat, and it addresses the same problem that AQM tries to address. So that is another thing to bear in mind as well, that this is not the only way to handle bloated buffers in the network. My personal opinion is that AQM has been trying to get deployed for a long time, and it might yet get deployed in corners. But at the same time, the endpoints have to do something anyways because they can't rely on AQM getting deployed throughout the network. So endpoints are going to try and address this if they care about the problem. Ultimately, buffer bloat affects endpoints, and if they care about it, they're going to try and do something with congestion controllers to address this problem. So it may not be an issue. I don't know that we'll resolve this today, the conflict between endpoint congestion control versus AQM, but that's definitely a direction in which we could go, and this becomes a non-problem at that point. The requirements change at that point. And so I'm not convinced that the requirements are written in stone either.
To be clear, John, what you're clarifying is that the requirement of using this as a way to do AQM may be less valuable going forward at some point. Who knows? Yeah. Okay.
Do you want to, Wesley? I didn't say it earlier, but I support option 1, which is do nothing, which is my default position in life, I guess. Like the risks. Yeah. I think Colin asked what the risks are. The risks are we increase the surface area of the protocol. It's more crap for middle boxes to get wrong. And the real potential is like, what are the risks of IPv6 hop by hop options and like the flow label, right? The risk is we spend 10 years and then we discover that someone did something wrong and then we work around that and it's just a lot of time to standardize something. For what ultimately I can see that the middle boxes that really need the information can hack around it independently of what we do, because there's obviously like spectral analysis and there's all sorts of toggles, and like you can actually do this in different ways. And ultimately, if you really need, like the middle boxes that really need this would probably fall back to TCP because they want to inspect other stuff other than just the RTT. So it does feel like a niche use case. Obviously, someone said enterprise networks this is really important, but there are probably other ways than just expanding the scope of what Quic is. This isn't even on the right layer, right? We're just piggybacking on Quic because it's getting specified, but it's not obvious that this should be specific to Quic.
That's true. Although I will say one benefit of putting it on this layer is that it is authenticated, and so it can't be changed.
It's available. That's the only reason it's
no. It can't be. You can't just some random peer in the middle can't like nuke
sure,
it and turn
but
it to zero.
so like the minute you say that the network ties this information to AQM, now as a sender, I have an incentive to manipulate this to get performance benefit, right? And like the whole spectrum of things changes. But we're saying this is an innocuous thing and this is needed, but it's not needed and like it doesn't have much requirements, right?
Yeah. I was just disagreeing with the one point about yeah.
So I'm still very much in favor, sorry, Philip Diesel. I'm still very much in favor with 3A because of a few things. First, I fear if you don't give this information, it might start a race of arms for passive measurements, passive determination of the RTT, and the machinery needed for this can be easily used for other stuff we much less want than measuring RTT. This is, in my expectation, much more dangerous. And the other thing is, if you have this mechanism, you can still embed some privacy. You can, for example, randomize the RTT send back by adding a few ones or removing a few ones, having a small delta on flipping it, making the RTT estimate for the pass still interesting and still usable for network learning, but getting some more privacy by just randomizing a little bit when you really flip your bits. Also, you have the possibility, if we think it will be, or if we sometimes find out that it's a bad idea, we can still say, okay, default to zeros, or just completely randomize it, and this problem is gone. But then you also have to take the burden of delaying your packets or with a random offset to make sure that the RTT is not estimatable anymore. By the way, it's then still estimatable, but in a much larger delta.
Before Gori, quick interject from the chairs. We have about 25 minutes, and we've been discussing whether it's worthwhile to do, like, either we keep on this and we basically burn until the end today, which is one option, or we try to squeeze in something else. I don't really have a preference. Can I get a show of hands? Who thinks we should actually keep discussing this until the session ends?
Are we still making progress, in other words? Hands, not mouths.
Hands. Yes, you
may.
Always.
Spencer Dawkins, the ostensibly responsible area director for Quic. Could I ask a couple of show of hands questions before you guys do?
Please do, yes.
How many people in this room understand the issue we've been talking at a level that is sufficient to where if that was their job explaining it to people, they would not starve to death? Understanding it well.
Martin, if your hand isn't up, you can't be our editor anymore.
Sure we can. So my concern as the responsible area director is that if I wanted to charter the PLUS working group, I would have taken the PLUS working group charter forward, right? I didn't do that. So this feels plus to me, and that's not working for me. What I was going to suggest was a couple of things. How many people in the room would like to know more about the issues we've been talking about?
Show your hands.
I would, but.
Which issues, Spencer?
Issues in network management that are caused by this.
So by the issue, I assume you mean the network management challenges that Quic might impose.
Right.
Yes, that's an excellent way to put it. Show of hands.
Yeah.
Less hands than we had experts, which is interesting.
Well, the experts obviously. All right.
All right. Do you have any other questions, Spencer?
No, but I've got a thing that I'd like the working group to cogitate over. One might not be surprised to discover that so the IEB and ISG have a joint retreat every year, and these days, and on the one day that the two retreats overlap, the IEB and ISG talked about this. Then the IEB met, the ISG met, and the ISG talked about it on Thursday. Then the ISG met, and the ISG talked about it on Friday. This is a big deal. This is a lot bigger deal than Quic, it feels like to me, by the way, that there are a lot of, there are probably a lot of other people in the IETF that should be at least as worried as the Quic working group is about some things. So that's number one. Number two, one of the things that happened there was that Ecker gave an excellent presentation helping the rest of the ISG understand the concerns better. And I mean, he had like a half an hour with slides. It wasn't like standing at the microphone interacting. And I found that to be extremely, extremely helpful. And it seems like to me, if that got a broader audience, it would be helpful. Ordinarily, it's not, okay, it's never the job of IETF participants to educate other IETF participants.
No?
It seems like to me that it might be helpful to make progress if we had a better understanding of what we're talking about here. In the Jabber rooms, it's like, are there well-known citations to things that would help the people who raised their hand the second time understand better? Because I mean, this is going to go one of two ways, right?
So one thing we could do, since Ecker is here and we might have parking lot time tomorrow, is to see if he feels capable to repeat that presentation or do a version of it tomorrow, if that helps, right?
I would never ask another area director to give a presentation during IETF week at the same IETF.
It's a possibility, right? Because people want to
talk about it with your document editor.
Right.
But I think the related thing on that is Singapore is not, if that doesn't happen, something like that doesn't happen, Singapore is not too late. Sure. And Singapore is not tomorrow.
Sure.
Okay, and that might even give a very talented and busy member of the community an opportunity to involve other people and launch them to do the work. That's something an area director would love if Ecker is anything like I am.
Right.
Now I'll go away.
Thank you very much, Spencer. So just not to preempt the folks who are in queue, but I mean, it's already pretty apparent to us, I think we're not going to be able to make a decision about this today. And I doubt we'll even be able to take any hums about it today.
No.
I think Spencer's absolutely correct that we need a lot more information and a lot more thought about this. But part of that is discussing it in the room. So let's continue, I think. Sorry, Ian?
I was going to ask whether it's possible to kill all options except for 3A from future consideration for the sake of practical.
I think,
I don't know if that really helps,
I
but
think there's
yeah.
proponents for option one.
Oh, okay.
But
Let's
that
talk
could
about
be-
one, I
that
think.
could be
One's
progress.
might be the most attractive approach.
I'm sorry?
Exposing sequence numbers appears to be what we've done in all transport protocols to date.
Sorry, say this again acoustically.
That's
I didn't hear it, Corey.
I love 1 and 2s and 3s.
Hey,
Corey, to the mic.
Can you say this again, please? I didn't hear you.
I shall talk slowly.
Hang on.
Right.
That's a scribe interrupt, that's allowable.
35. Ian.
I asked if whether though we could not have clarification on whether we wanted to move forward with any of these proposals, whether we could agree if we were going to move forward with something, we would pick one, partially just for the sake of like us not going through this whole talk all over again. So, and we have a PR for one of them as well, which is rather nice. That's.
Now, I argue that I'm not going to mention any options. Right, all transport protocols to date appear to have had sequence numbers in, and the aim there was not necessarily to annoy operators. Transport and operators have worked together, so let's keep the conversation about how transport protocols work and how we interact with networks. Networks are constantly changing. The transport area is probably one of the few areas where we do a lot of research to support this. One of the nice things about exposing some of this is it gives researchers and other people a body of work to bring here to check whether these congestion control mechanisms interact goodly or badly. The AQM thing is only a straw man. There are plenty of other mechanisms out there in the network which will impact transport performance. So if we want to move forward, we want to evolve, we want to live with a network that's changing, I suggest we keep something in here that can be correlated in that data set.
Hi, Colin Perkins. So, Gary and Miria said a lot of what I want to say, probably in a better way than I can. The other point, Gary and Miria said a lot of what I want to say, probably in a better way than I can. The other point I wanted to bring up, I think, I mean, DKG raised a lot of important, privacy issues and so on. I tend to believe that those are not solvable unless you run Tor or unless you take active countermeasures to stop them. I think any transport protocol, you can do the analysis to get RTT to that level of accuracy, whether or not there's anything built into the transport to help you do it, unless you actively try to obscure the RTT. The mechanisms, even if we do nothing, I think those risks exist. And I think we need to consider whether we are trying to solve a problem that is just not solvable. And if it's not solvable, then maybe the management issues should also have some weight.
Ted Hardy, I got up to reply to a couple of points made by Spencer and to volunteer something related to the comments made by Spencer. The first was Spencer made a parallel between this proposal and Plus. I think that parallel was ill-drawn. Plus is considerably different in scope than this proposal, which I believe is as drawn as minimally as the tight mind of Christian Wiedema could make it, and I admire it for that capability. Second, I thoroughly agree that the conversation which happened in the ISG and IEB retreats is ongoing and important. I'd like to volunteer to send to this working group the slide deck that Brian and I put together for that retreat as input to the discussion, if we're interested in having some portion of it here. As a brief preview, I will tell you it's all about explicitness of signaling and the efforts to remove everything that's an inference that we can from the network. And I believe that one of the things I like about this is, and I certainly would never make it a required part of the operation of the protocol, is that it is an explicit signal. The endpoints turn it on in order to tell the network something, when they want the network to know it. And being able to turn it on and off for that purpose is, I believe, a critical part of the functioning of any signal of this type that's going to meet the privacy concerns that people do have. I'm certainly willing to be educated more on privacy concerns. The traffic analysis topic is also one that we're working on actively inside the PrivSec program, and more information is always good. As I said before, I don't want to prejudge the outcome of the discussion balancing these two things, but I think we need to be as open-minded to the importance of having this information for network planning as we are to the information of the importance of suppressing this information for privacy. I agree with Ecker, we may have our thumb on the scales, but we have to actually fill the scales to do our job properly.
Jana Iyengar, using the example of past transports or existing transports is I think, a very poor way to discuss this. Quic is not, and very deliberately so, like TCP or SCTV, in that it is encrypted, and the headers are encrypted deliberately. They're very deliberately encrypted to avoid ossification, to avoid any leakage that you might have, and those things are a key part of what Quic is. The fact that network operators have used transport information in the past, and I said this at several venues in the past, that they have used information that's available in TCP headers is not because TCP was kind enough to share them, it's because TCP didn't know better. And network operators used whatever was available to them. As I said earlier, we know that Google Quic has already been ossified. It's not because we wanted to share that information, it's because the 1 byte of information that we shared with the network was taken on by a firewall that decided to use it to identify Quic and didn't allow us to change the flags byte. This is a real question. I mean, it's not that we are playing nicely with middle boxes with TCP. We are trying to change TCP and we can't, because middle boxes have ossified it. I don't think it's fair at all to say that we are having a good thing going on there. I think that's a complete mischaracterization. Separately, I think that on the question of unsolvable privacy concerns, it's a very broad statement. I don't think we are in a position to say what privacy concerns are solvable and what aren't. But what we are in a position to say is what information we expose and what we do not. And to that, I think I agree with what Ted was pointing out, that there are questions on both sides for us to consider. On the management of networks question, I have spoken over the past year, not just me. I think Ian and I both have been talking to operators over the past couple of years, and we've been trying to clean whatever we can out of them in terms of trying to understand what information they might need, what information they could use, and so on and so forth. And the answers have been generally, I think, varying from lukewarm to sort of, yes, we'd like it, but if you didn't have it, we'd still live. It's not been, yes, we need it, or else we're going to shut the network down, or we're going to shut down Quic, which is important, which is really important, because one of the questions about whether this can be optional or not, I don't know that in practice it's ever going to end up being optional, because if an operator really cares about it, they're going to end up saying, I'm not going to allow Quic traffic through. That doesn't actually negotiate this option. So either it's really important and we make it mandatory, or it's not. I've not gotten any signal that it's really important.
Hi, I'm Dirk Kutscher. So I, and I think many here in this room, agree that so knowledge about RTT is useful for network planning and performance management. But I think we are actually mixing up utility and requirements here, right? So with the potential, with the, I think, already visible privacy risks here, I don't think we can decide on that without having actually seen real evidence that there is a problem and we need to do something like this. So even today, I heard many people saying, I feel there is a requirement in this and that network. I think we really should spend more cycles on actually demonstrating this.
Sanjay Mishra, Verizon. Just a couple of observations. So I think when we had the charter discussion, quite a bit of time was spent about network monitoring and network management, I should say. So I think at the end of those discussions, and then what was clear was that there certainly is a need for network management in order to make sure that there's some level of accountability in terms of how Quic is performing, and some of the things that we had already agreed upon. So now here we are discussing a solution that might be fitting that charter requirement. So if we go back and now when the solution is presented and then question what was already agreed in the charter is then, I think in ways we're taking steps back. So certainly fine to discuss this, that maybe we should, tie this back to the charter and go back and make sure that, we're all clear with the charter and what, Quic is going to be delivering. So it behooves upon us to, go back and, relook at the charter if the question comes up when we're looking at the solution.
So the charter says that the group should consider current practices, right?
It does. Yeah,
that's
it
what
does.
It says.
Yeah. And so, so this
but
is
also
part of the consideration, right?
It also says the Quic protocol need not be defined to enable each of these abilities or enable them in the way as they are enabled by TCP when used with TLS 1.3. But the working group must consider, blah, blah, blah.
That's what we're doing.
That's what we're doing now.
Right. And then just wanted to also make sure that one of the things that, Ian, in your presentation at the very upfront, I think maybe the second sentence or the second word in the presentation, it says that almost all the data is encrypted. So I think, let's just be careful about, the concerns that, that might be there with exposing the information in the RTT. But, as you said, that's, much of the data is encrypted, most of it. So we've got to balance that. We want to make sure that Quic is deployable and we can measure how well it is performing. And I think one of the reasons why we're having this discussion and working group in Quic is because the Google's implementation of Quic has been successful and they've been able to demonstrate that look how it improves over TCP. So I think we've seen the evidence that with the measurement that you have shown in the past. So this is probably not a whole lot different that allows us the tool to do the measurements.
Yeah.
I want to come back to Jana's example because I think that's actually a good example to underline Ted's point. Because the information that were ossified here, and it's really sad to see that, and it's a real problem, was information that was not meant to be shared with network. Just because it was available and ossified. So the point actually is whenever we share information with the network, it should be explicitly only for the network and it should not have any dependencies on the internals of the protocol so that we still be able to evolve the protocol even if there is an ossification or whatever. So that has to be separated and I think that's a lesson learned from the past. And the other point I wanted to come back on last question you had towards like what's the difference, and I said complexity and actually difference between like what you can do today and giving the signal. And complexity is one point, accuracy is one point. So to go a little bit more into detail, you can look at like traffic characteristics and behavior and you see the flow and you see the user or whatever. And at some point you can get a round trip time measurement and then you know the round trip time of that flow. But like with this mechanism, you get like round-trip measurements all the time, so you get more information. You can actually use it for your network management. You can figure out what's happening right now. So while you still have the security risk if you don't do it, because round-trip time can be seen based on your traffic characteristics, you don't get any of the advantage by doing it. Also, it doesn't scale. So while you can probably do this through traffic detection for like most of the flows. Maybe you cannot do it for everything, while here you have like an explicit signal that actually gives you information you need for your network monitoring and troubleshooting.
Just to interject, we're going to cut the queues because we do want to be able to wrap up.
Yeah. If I can sort of channel what I think DKG would say to this, and he can correct me, is that it's a different quality of information, and that's the difference, right? One is that it's actually a timely signal that's there, and you can react to it in a timely manner. The other one requires you to do some machine.
Lars, this is individual?
Sorry?
Is this Lars'
Yes.
individual or Lars' chair? I'm just trying to write it down right.
It is individual. Thank you. But I think that is what DKG said. Right? And then the question is, what kind of information, if any, should the group?
It's a different kind of information. That's what I'm saying as well. And on one hand, and I think for both kind of informations, you have the same privacy risk. While one of the information is also useful for what we want it for.
So I should not have opened that.
You opened the can of worms.
I'll be very quick. You said my name 3 times and I appeared at the mic.
I remember that.
I think that what I just heard Mirya say is that one approach provides you with massive, pervasive monitoring information, and the other approach provides you with targeted monitoring capabilities.
Okay.
No, one approach provides you like one round trip time measurement and the other one provides you information over time, and that's just like two completely different information. It doesn't matter like how much bytes it take to store the information or whatever.
Yeah, I think we agree. Thank you.
Okay.
Andrew, bring us home.
So I think the thing is, if we do this and expose this information, whether or not you do it, you still have to take active measures to avoid being triangulated by your RTT, right?
Yeah, the handshake is a good example.
Yes,
right.
exactly.
You would have to delay the handshake computation for.
And you have to do something to screw up the autocorrelation structure of your traffic, which you can do. But Ecker's point that this is introducing edges through the hash function and therefore leaking part of the session key, that is a very important thing, because on top of that, the network operator can play with your RTT by actively inducing delays to expand their search space on that key, right? Yeah, okay.
Ted?
In any case, that expands the attack surface of the protocol somewhat. On the other hand, as a network operator, what am I interested in? I'm interested in the statistical characteristics of the traffic through my network, and I don't care usually about any particular flow. I can get that anyway, right? I can get that with reasonably high temporal resolution if I'm prepared to do some fancy statistics, and those are quite computationally cheap for me. So I'm leaning towards, let's not do this, because it potentially leaks crypto information. It doesn't help the network operator substantially. So, as an AQM developer, I don't need to know the RTT. What I actually need to know is the autocorrelation structure of the traffic, and all I need to do is measure that directly.
Andrew, may I make a request? The paper you cited?
Yes.
Would you mind sending that to the Quic mailing list?
You and Jana already have it, so you can do that.
Oh, okay.
Yes.
Okay, please forward it on.
All right.
Okay, we've only got 4 minutes left. Thank you. You're good to go. Thank you, Ian. Thank you for your service. So let's try and cut down the search space just a tiny bit. Does anyone, show of hands, are they interested in keeping option 2 or option 3 on the table, or are we really just talking about option 1, option 3A, or something else which hasn't been discussed? Any interest in option 2 or 3? Hands? Please.
I have interest in option 2. I am willing to set it aside if it makes this terminate in 2017.
It probably will. We can always come back to it.
Side bet?
Sorry?
Side bet. I'll take a side bet.
No bet. Actually help or
well, maybe we don't. So we've been trying to, or Mark has been trying to slice this somehow, and let's do this, and if it goes horribly wrong, then we get drunk afterwards.
We're very close to the bar. So, one of the things that struck me as I sat here and listened was that my editor is not fun today, is that, one side of this is, there's potential privacy exposure and we don't know what it is, and some people are asserting, well, we should know what it is, and some people are saying that no, we have a higher bar than that for security and privacy issues. And there's another side which didn't get quite as much attention, but we've talked about before, especially in Paris, which is the network management side of things and the needs there. And people are asserting that we need this information for network management, but it's not entirely clear, and I think Andrew just summed that up really well, that this information can't be got through other means. So we have partial information on both sides. And I'm wondering if we can think about the priorities between them. We think about security and privacy in this organization, from what I've seen, in a pretty fundamentally different way than lots of other things. And so these are the questions that I was scribbling on to figure if it would help us think about those priorities. Does this make sense at all? And I see the IAB chair getting up. Oh, he's going away. No, he's getting up. Okay, I just see Ted getting up then.
2 IB members, all right.
No, I just see Ted and Martin probably.
How many IB members can we get? Up,
So Martin Thompson, should a concrete privacy or security violation be identified to preclude adopting this proposal? What you're trying to say is that the requirement for rejecting the addition of any mechanism is a specific privacy violation.
Yes.
We want to answer that particular question.
I'm so certain this can be worded much better. Yes.
Yeah. So that's maybe a bit.
Give
maybe
me
needs a bit
words.
of work, but I'll get you some words in a second.
Okay.
I'm not even sure. Sorry, I just wanted to add. I'm not even sure that that's going to give us signal on the things that we want by asking that question. But I want to think about it a bit more.
Yeah, that's what I'm wondering is if this is useful or not.
Ted Hardy, in the hopes that you get drunk for much better reasons than he is, I present two postulates, and I hope you can confirm them. One, there is no chance we're doing this for the next implementation draft. Is
No,
that
hell
correct?
no.
Okay.
No.
Given that we're not going to be trying to do this for the next implementation draft, and we had a lot of discussion where we already know that people want to share information, including Andrew's draft, the thing I'm going to send, some papers that DKG also wants to share. I think that we have already established through discussion that the information that the working group currently has is less than it wants. So I believe
that's a fair statement.
That you could defer the decision on this based on the obvious lack of consensus, the desire for more information, and the fact that it would be much better to be drunk for a very different reason.
Oh, let's be very clear. I'm not saying this is making a decision. I'm just trying to figure out how to guide the information gathering process.
So,
yeah.
So we were at TLS one yesterday and quite impressed with the, no, so but one thing we could do, right, is we could find, let's call them champions for each of the two approaches, right? Basically option 1 and option some 3A or whatever it looks like that exposes information and get them to do a pitch, like Stephen Farrell yesterday did very passionately, for example, and the other side did as well in TLS about the trade-offs, and maybe that might enlighten the discussion here. I would like those. So if we do this, I would prefer as a chair if that's not the editors because they are very, very busy already. But that's just a preference.
Mostly, we want to come to our next meeting in Singapore and have more information.
Yes.
Yeah. Yeah.
So I heard on both sides concerns that there are also concerns that we don't know about yet. And I think we can collect information until whatever.
So I think that's
the next 3 years. So how do we terminate this?
Mark's proposal was on concrete things, right? Basically, things where for example, on the network management side, some operators say, come up with a case that say, here's a case where we absolutely need this information to be exposed by the flows, because otherwise this fails, right?
Let's not open the queues. The room is emptying because we're out of time. So
we have a session tomorrow morning where we're not really going to talk about this anymore.
No, we're not going to talk about this anymore.
But we have a list.
Why don't we do this? Why don't we close the meeting for now? And folks who are interested in kicking this can down the road, come on up to the front of the room. We'll have a chat about how we can have a more productive discussion in Singapore.
Bring beer.
And bring beer. Cocktails. All right, thank you all. We'll see you tomorrow.
Where are the blue sheets?
Oh, yes, blue sheets, please.
On our table.
Oh, they're right here. Does anyone need a blue sheet?
Thank you.
Come up if you do. Thank you. Sure, you're a champion.
Yeah.